specifically the Barton reaction. Now here the Barton reaction, why they have not given in your syllabus, I don't know, but it is equally very important reaction because the very specific functional group has been involved over here, that is a nitroso group. All right. So the Barton reaction, what are the characteristics of the Barton reaction here? So the characteristics are, the first thing, this is a uh, intramolecular rearrangement reaction. This is a intramolecular rearrangement. So whatever the rearrangements take place over here, it is within the molecule. Within the molecule. So this is the most important point to be remembered. And the second point here in the Barton reaction is the abstraction of the hydrogen. Extraction of hydrogen will be from delta position. Will be from delta position. So these are the two important points to be remembered over here. Now, in the net set examination, of course, they will check your the knowledge about the reaction mechanism and the organometallics and the reducing agent, etc., etc. If you know proper reaction mechanism, if you know other name reactions, then you can easily solve it. They will not give you directly the substrates or the starting material. You have to create the starting material. They will give you the reaction conditions always. So in all the reactions, the first thing we have to think about, that is the role of reagents which are given on that particular arrow. So what are the reaction conditions which are involved over there, and accordingly we try to get the products. So that product will be your starting material. So they naturally the difficulty level is very high. So in that case, you have to remember, you have to apply the knowledge of the other part of the chemistry, that is the reaction mechanism, the other name reactions. Then you can easily solve the reactions. As we know that in the photochemical reactions, the reaction is what we feel or what we expect. They are not like that, because the other basic or the we have to apply the other aspects of the basic chemistry also in overall in the photochemical reaction. So same aspect in the Barton reaction. That's why I'm focusing on this reaction, because again lot of chemistry has been involved in those reactions. Now always in the photochemical reaction, we came through so many starting materials. All right. So in the Nourish type 1, which one is the starting material? Nourish type 2, the starting material. Then we have seen the Paterno-Pucci reaction. Then we have seen also the photophrase migration, the photochemistry of the analytes, and these photochemistry of enones, the photochemistry of cyclodinones, etc., etc. So these are the various name reactions we have seen in last few lectures, and also we have also discussed the various substrates or various starting materials. So remembering all those starting material is very important, because the complete game is around the starting material, and that starting material will give you that particular name reaction, as we always discussed in the previous in your previous semester also. So all the name reactions, they are designed on the basis of starting material by the respective scientist. All right. Now, why I am focusing on the Barton reaction? Because again, this is a very peculiar starting material they are using. Now the starting material is nitroso base, or the substrate is a nitroso group, or the starting material contains nitroso group. So if such type of molecule you can see, so directly you can apply the Barton reaction over here. Now, now I can write the overall reaction and I will give you the, so this is a nitroso compound, and you will get the formation of, or this is a product. This is a product. In general, we have seen the alcohols, and so this is a nitroso group. Now, what you can observe over here, you can see that the uh, this, or so you can see that there will be the exchange of these two groups. All right, you can see that the exchange of that, this NO is shifted over here, है ना? This NO is shifted over here, and this H will is coming over here. तो इतना आसान है नहीं है जितना ये दिख रहा है, because the chemistry is the mechanism, when we see the mechanism, it is very important that why this NO will be coming out after H nu. So we know that so this is a, actually this is a very weak bond. So this is a very big bond. So whenever we induce H nu, the substrate is induced by H nu, then this is a very big bond. Why this is a very big bond? Because when we see the structure of this molecule, so there are a lot of lone pair of electrons are there, and because of the uh, crowdiness of the electrons, so there will be lot of repulsion, and as we know that every molecule attains a stability. So after H nu, so this is the only driving force that this will be breakdown. There will be a cleavage. So that cleavage will take place. Now let us see the mechanism. But before that, we must know that which is the driving force that this bond will be disconnected, or there will be a cleavage at this bond, or the homolysis at this particular bond. Now let us see the mechanism. Now what is the mechanism? Now I'll take the original molecule, but please remember, in this particular substrate, the examiner will give you different substrate. Then you have to find out your own starting material. That will be the product of that particular reaction, and then you can start the reaction, photochemical reaction. So you have to first design your own molecule, and then you can start the photochemical reactions. So such type of reactions, they are given in the net set. They are very important. The Barton reaction is equally important in the net set. Now after H nu, as I told you that this is a very weak bond because of the electron density. High electron density leads the repulsion in that particular moiety. So that's why the immediately there will be a cleavage over there, and you will get the formation of so oxo and nitroso. Now again, as we know that the oxo radicals are also very reactive, है ना? ये हमने कहाँ देखा था? पटर्नो बुची में देखा था कि oxo radicals are very reactive. So what is highly reactive है? So what we have to stabilize it, so naturally so it will abstract the hydrogen, but not in terms of the, so again it will be broken down into a radical. So radical will give you radical reaction, that we have to remember always. So it produces this radical, and this OH will be abstract, this H will be abstracted. So this is a simple mechanism till date we have seen. Now here what is important thing is, this is a alpha, beta, gamma and delta. So delta H, abstraction of delta H. Yeah, why this delta H is most important, that this will form a six-membered intermediate. And that is why you will get the very stable intermediate, which is a six-member. All right. So this six-member intermediate will be again the another driving force to abstract the hydrogen from the delta position. Now here you will have this. Now what is how it will be stabilized? That nitroso group is already there in the reaction mixture, so they will combine with each other, and you will get the product. So this is the mechanism. Looks very simple, but whenever there is a chemistry, जैसे मैंने बताया कि जितना आसान होता है उतना आसान नहीं दिखता है, उतना आसान होता नहीं है. All right. Now this something we need to rearrange over here, as we know that. So this is a product, but beyond this, again the chemistry, more chemistry has been involved over here. Now, which type of chemistry? Like the role of substituents at the carbon atoms. The role of substituents at the this delta carbon atom. So delta carbon पे कौन से substituents है, इससे भी product जो है आपको reaction आगे बढ़ाने में आसानी होगी. Now let us see the role of substituents, means the R and R dash. So in the first case, if your R is equal to H and R dash is equal to CH3. Okay. In the second case, if your R is equal to H and your R dash is also equal to H. And in the third case, so I'm putting this as a like this. So in the third case, if R is equal to CH3 or and R is equal to CH3. Okay. Now why I am stressing on this particular the role of substituent is because here this NO has a very typical behavior. So how what type of behavior it has? See, it has oxygen is highly electronegative, nitrogen is having lone pair of electrons. तो ये शांत नहीं बैठेंगे, ये हमेशा ये अभी भी अपने आप को अनस्टेबलाइज महसूस कर रहे हैं, तो ये अपने आप को स्टेबलाइज करने की हमेशा कोशिश करेंगे. सो लेट अस सी फर्स्ट केस व्हेन योर R is equal to H and your R dash is equal to CH3. Now I am drawing the separate molecule. So it is done, it is okay. Now this OH iska kaam ho gaya hai. Now we will focus on this particular site when your R is H and RH. So what is happening? This because of NO, this hydrogen becomes more acidic. This hydrogen becomes more acidic. If it becomes more acidic, so naturally it will be protonated. So protonation will take place, and this oxygen will abstract this hydrogen. Okay. So after protonation, let us see the scenario. So CH3. So this will be oxygen will abstracted this hydrogen, and this bond will be collapse over here. So naturally there will be a double bond, nitrogen and oxygen. So this type of moiety is going to form ultimate. So when your R is equal to H and R dash is equal to this thing, so your so oximes are going to form. All right. So this is your product, ultimate product. All right. Then when your R is equal to H and R dash is equal to CH3, so this is your product. Now let us see the second case. Let us see the second case. What is the second case? What is the second case? Second case is R is equal to H and R is equal to H. Now again, I can redraw the structure. Oxygen, H, H and NO. Now as we know that this this phenomena is going to occur, that this is a protonated and this oxygen abstract this acidic hydrogen, this bond will be collapsed over here and you will get the formation of oximes. You will get the formation of oxime. ये step repeat हो रहा है यहाँ पर. So now here again this is more acidic, as we know that. अब ये डब्बा पद्धति से तो वाटर मॉलिक्यूल हमें रिमूव नहीं करना है, ये हमेशा आपको बोलती हूँ, ठीक है. बट there is a mechanism, I always taught you the mechanism of dehydration, removal of water molecule, so this molecule will be removed. कैसे होगा? पहले तो प्रोटॉन निकल के आएगा, ठीक है. फिर ये प्रोटॉन है, ये OH इसको abstract करेगा. In that way the water molecule can be removed. अब ये mechanism मैं आपको यहाँ पर नहीं बताने वाले, because we know that we have already discussed in your earlier semesters. All right. So what will be the next this thing? So this will be collapse over here and this will be coming out and you will get, now this is supposed to be a carbon and this is the nitrogen. So this is your product again when both are H, when both the substituents are H. And what will be the next what will be the third possibility when your RH, when your R is CH3, when R is equal to CH3 and R dash is equal to CH3. Now again draw the proper structure. Okay, so what you suggest over here? So no hydrogen is present, है ना? No hydrogen is present, no acidic hydrogen. Actually, no acidic hydrogen is present over here. So this is the product when R is equal to CH3 and R is equal to CH3. Okay, so the so you have to terminate the reaction in this fashion. यहाँ आपको रुकना नहीं है. If यहाँ पर रुकेंगे आप तो कोई बात नहीं है, but as a senior students and as a higher the students in the higher classes, they must know the advanced chemistry and also the basic knowledge. So they have to terminate the reaction in this manner if your substituents are given. All right, substituents अगर आपके इस प्रकार के दिए हुए हैं तो आपको रिएक्शन तो यहाँ पर नहीं रुकना है, आपको इसको आगे भी बढ़ाना है. ये बात आपको अच्छे से याद रखना है. All right, so on the basis of this Barton reaction, I would like to explain one of the most important एग्जाम्पल हमेशा मैं बोलती हूँ कि मैं बहुत एक्सक्लूसिव एग्जाम्पल्स लेती हूँ, क्योंकि उसमें अगेन मोर एंड मोर केमिस्ट्री, आपको पुरानी केमिस्ट्री आपको याद दिलाना बहुत जरूरी होता है. सो लेट अस सी सम एग्जाम्पल्स. So the first example is, it looks very simple. Then another example we can see, the it looks very complicated, but एग्जामिनेशन में बहुत सिंपल तो कोई बात आती ही नहीं है, तो आपको थोड़ा कॉम्प्लिकेटेड मॉलिक्यूल को हैंडल करना जरूरी होता है, राइट. अब ये है आपका रिएक्शन सेंटर. ऑलराइट, ये है आपका, इसको मैं थोड़ा ठीक से लिखती हूँ. ऑलराइट, एंड so this is a substrate for your Barton reaction, and the third substrate is also again the basic chemistry. Here if you have to apply the knowledge of basic chemistry, this is the third molecule where we, all right. So these are the three substrates. As I told you that the exclusive example I always explain you, simple molecule तो हमने देखा है यहाँ पर. Now let us see the mechanism in this molecule. So mechanism is, so सबसे पहले हमने नाइट्रोसो ग्रुप को इरेडिएट करके हमें रेडिकल निकालना है. So this is a oxo radical and we have a nitroso radical. Now whenever there is a ISC take place, we know that this is a alpha, beta, gamma and delta. तो यहाँ पर अभी हमें क्या करना है, यहाँ पर एक हाइड्रोजन हमें दिखाई देता है, और हमें नेक्स्ट आप क्या करोगे कि आप, जाहिर है आप डेल्टा से, क्योंकि एक हाइड्रोजन आपको दिख रहा है ना, है ना, यहाँ पर जो है हाइड्रोजन, ये आप इमीडिएट इसको एब्स्ट्रैक्ट करोगे और आप H को लगा दोगे, और यहाँ पर आपको, आप इसको फ्री रेडिकल में कन्वर्ट करोगे नॉर्मल वे से, करोगे ना.
यस.
हाँ. yes, लेकिन वैसा नहीं करना है. क्यों नहीं करना है? क्योंकि sp2 रेडिकल क्या होता है, क्या होता है, फॉर्म होता है कि sp2 रेडिकल, हाँ, अगर ये हाइड्रोजन यहां से निकलेगा तो रेडिकल कहां पर आएगा, बताओ। क्या इस प्रकार का मॉलिक्यूल एक्सेप्टेड है? बिकॉज sp2 radicals आर हाईली अनस्टेबल, सो इस प्रकार का कुछ मैकेनिज्म हमें कभी भी नहीं मिलेगा. सो प्लीज रिमेंबर, सो इन सच केसेस व्हाट इज द criteria and what knowledge we have to apply, that we have to go with. So in this case what is going to happen is the double bond will be, there will be again one more cleavage is happening over here. So instead of abstraction, the homolytic fusion will be happening over here. Okay, so that these two free radicals are now ready for the further reaction. ना मैं हमेशा बोलती हूँ कि अगर इस प्रकार का कुछ हमें दिखाई देता है तो सबसे पहले देखो हमें ये जो लॉन्ग चेन यहाँ पर दिखाई देती है. सो अकॉर्डिंग टू द बोल्डविन्स रूल जो कहता है कि बोल्डविन्स रूल क्या है, रिंग फॉर्मेशन के आप पढ़ लेना अच्छे से. बोल्डविन्स रूल कहता है कि अगर मॉलिक्यूल को स्टेबिलिटी मिलती है रिंग फॉर्मेशन से तो रिंग फॉर्म करो, और ऐसे रिंग फॉर्म करो. तो इसमें हम हमेशा बोलते हैं कि 6 मेंबर्ड रिंग इज मोर स्टेबल, बट अकॉर्डिंग टू द बोल्डविन्स रूल इट इज, इफ इट इज 5 मेंबर्ड. अब देखो यहाँ पर एक एक दो तीन चार पांच और 6. So 5-membered ring is also possible and 6-membered ring is also possible. But Baldwin rule के according 5-membered ring पहले form होती है rather than the 6-membered ring. तो अगर इसमें ऑप्शन आता है तो 5-membered ring will form first. अगर 6 और 7 के बीच में अगर हमें वो आता है तो 6 पहले फॉर्म होगी, या 7 और 8 के बीच में अगर है तो 7 फॉर्म होगी. So this is how the Baldwin's rule, on the basis of Baldwin's rule, so we can form a 5-membered ring over here. Now what I will, according to the Baldwin rule, what I can do, I will form a 5-membered ring. Then so that, so because there are two free radicals at both the centers, so I can draw this 5-membered ring. ऑल राइट. और ये जो फ्रैगमेंट है, ये कुछ फ्लैजिला का तरह, इसको मैं यहाँ पर पुट अप करके आई कैन ड्रॉ द स्ट्रक्चर लाइक दिस. सो दिस इज अ CH2 as a free radical. Now the NO is again it is already there, so they will form a bond and you will get this type of structure in this molecule. So H and NO. All right. Now as we know that R and R, है ना, both R are H. So let us terminate the reaction with the proper knowledge of chemistry. So we can terminate this with the H double bond NOH. All right. So again, with the removal of water molecule, this will be collapsed over here, this will be coming out, and in this way you can also CN or C triple bond N. So this will be your product. All right, समझ में आया ये mechanism? Why this is exclusive mechanism? Because we have used a certain different type of chemistry, that is at Baldwin's rule, where the ring closure, the priority of the ring closure has been explained over here. आप अच्छे से पढ़ लो Baldwin's rule बुक में, या फिर आप गूगल भी कर सकते हो, it is given over there. and you can get the priority of the ring formation if 5/6 or 6/7 or 7/8, etc., etc. So this is the way you can form the ring, and further the chemistry of protonation and deprotonation, you can form the final product. समझ में आया ये रिएक्शन?
Yes,
हम
ma'am.
Yes, ma'am.
यहाँ पर क्यों नहीं हमने ये जो पर्टिकुलर सेंटर है, ये अगर मैं आपको बताती नहीं तो आप इजीली इसमें से जो है ये वाला जो हाइड्रोजन है आप उसको बराबर एब्स्ट्रैक्ट कर लेते यहाँ पे, और ये यहाँ पर आप उसको अच्छे से OH करके आप यहीं पे खत्म कर देते। लेकिन आपको ये पता होना चाहिए कि हम डबल बॉन्ड पे कभी भी फ्री रेडिकल लगाते हैं, हाँ, यहाँ पर ये वाले सेंटर पे कभी आएगा नहीं आएगा, बिकॉज sp2 free radicals are always unstable, they are not formed usually, so that's why this chemistry doesn't work. And then we have to see for the second option where double bond undergo homolysis, where two radicals, again now there are three radicals in the same mechanism in the same moiety, and two radicals will form a ring which follows a Baldwin's rule. 5-membered ring is showing the more priority over 6-membered ring. So we are forming a 5-membered ring, and the rest of the chemistry we have explained in the first example. All right. So this is an exclusive example where the some more basic chemistry has been involved. So I hope you understand this thing. Now let us see the other example. Let us see the other example. इतना समझ में आया आप लोगों को?
Yes, ma'am.
Yes, ma'am.
ओके, चलो तो अभी हम लोग दूसरे मॉलिक्यूल की तरफ बढ़ते हैं। अब ये मॉलिक्यूल तो दिखने में बड़ा ही आपको दिख रहा है ना, बहुत कॉम्प्लिकेटेड दिख रहा है, लेकिन आपको सिर्फ आइडेंटिफाई करना है, जो साइट आपको आइडेंटिफाई करना है। आप एक बार अगर साइट आइडेंटिफाई कर पाओगे, सो देर इज नो बिग इश्यू ओवर हियर। नाउ हियर द फर्स्ट, यहाँ से आपको साइट को आइडेंटिफाई करना है। सो विच डेल्ट, आपको पहले क्या आइडेंटिफाई करना है कि सबस्ट्रेट, your substrate contains nitroso group, and the another possibility is the delta hydrogen. आपको एक टर्मिनल पे आपको चाहिए नाइट्रोसो ग्रुप, और दूसरे टर्मिनल को में आपको चाहिए डेल्टा H। ठीक है, तो हम देखते हैं कि यहाँ पर डेल्टा H कहाँ पर हमें मिलता है। ऑल राइट, सो लेट अस सी। So what is this? This is nothing but the CH3. This is nothing but the CH3. All right. So this is also CH3. So this is alpha, beta, gamma and delta. चलो, अल्फा बीटा गैमा डेल्टा H भी हमारे पास है, नाइट्रोसो भी है, यहाँ पर भी है अल्फा बीटा, अल्फा बीटा, नहीं ये थोड़ा मेरा ना गलत हो गया है, वेट वेट वेट, मैंने गलती से दूसरी जगह पे लगाया, रुक जाओ भाई। ऑलराइट, यहाँ पर है, हाँ यहाँ पर है मेरा CH3। ऑलराइट, सो अल्फा बीटा गैमा एंड डेल्टा। अब दो सेंटर्स है जहां से ये डेल्टा H को एब्स्ट्रैक्ट कर सकता है। नाउ विच वन इज द मोर फिजिबल, इसलिए मैं बोल रही हूँ कि दिस इज अ वेरी टिपिकल एग्जांपल ऑफ बेसिक केमिस्ट्री, है ना। दो अभी सेंटर्स दिख रहे हैं ना आपको यहाँ पे, दिख रहा है ना?
हाँ।
Yes, ma'am.
हाँ, दोनों देखो, ये एक सेंटर है, ये एक साइट आपको मिल रही है रिएक्शन करने के लिए, और आपको दूसरी भी साइट मिल रही है रिएक्शन करने के लिए। ये है आपकी दूसरी साइट। ऑल राइट, तो आप अपने हिसाब से मुझे बताएंगे कि आपको कहाँ से प्रोटॉन एब्स्ट्रैक्ट करना है। दोनों जगह से तो नहीं हो सकती, किसी एक जगह से हो सकती है। सो विच साइट इज मोर प्रेफर्ड साइट एंड व्हाई? प्लीज गिव मी जस्टिफिकेशन। बाकी स्केलेटन को छोड़ दो, आप सिर्फ वो साइट देखो, रिएक्शन साइट। यस, बंद हो गया है क्या मेरा माइक्रोफोन?
नहीं।
Like that.
चालू है ना? हाँ, तो करो अभी, बताओ तो। So here another basic केमिस्ट्री का जो और एक फंडामेंटल है कि हाइड्रोजन विल बी सो हाइड्रोजन विल बी abstracted दिख रहा है ना? मेरा हैंडराइटिंग दिख रहा है सबको?
Yes,
Yes,
ma'am.
ma'am.
Okay, so H will be abstracted from that site, where electron withdrawing group is present. Electron withdrawing group is present. जिसके नेबर में इलेक्ट्रॉन ग्रुप हो, वहां से H जो है वो इजीली एब्स्ट्रैक्ट हो सकता है, ऐसा हमारा नियम बोल रहा है। तो देखो अभी आप यहाँ पर कोई इलेक्ट्रॉन विड्रॉइंग ग्रुप है इसके नेबर में, इसके नेबर में कोई है इलेक्ट्रॉन, यहाँ पर ये वाला जो सेंटर है, उल्टा ये जो है इलेक्ट्रॉन डोनर है, डबल बॉन्ड। ऑलराइट, हम्म,
Yes, ma'am.
लेकिन इसके बाजू में कौन है? though it is not present in the next but next carbon atom, so the inductive effect is always there. So this site represents the electron withdrawing character. So this complete site represents the electron withdrawing character. All right, now this is a electron withdrawing zone, electron withdrawing zone, ये पूरा जोन ही है। यहाँ पर ये एक ऑक्सीजन है, ये एक ऑक्सीजन है, तो ये काफी इलेक्ट्रॉन विड्रॉइंग जोन यहाँ पर तैयार हो गया, और इसके इमीडिएट बाजू में हमारा जो है हाइड्रोजन है। तो नियम बोल रहा है कि H will be abstracted from that site where the electron withdrawing group is present. So or nearby also we can say that. So we can say that here there are the competition between two sides, one side and two side. So the priority we can give to this particular side, blue side, where the electron zone is present, because here uh, the electron withdrawing zone is not present over here. So we can give the priority of this particular site in which the nearby site will be a electron withdrawing site. All right, so let us see the mechanism. We can start the mechanism and we can see the product itself. So I feel that you understand the mechanism. So can I write directly the product or should I put mechanism? बताओ, मैकेनिज्म की जरूरत पड़ेगी अभी?
नहीं मैम।
नहीं मैम, कर
हाँ,
लें।
कर लेंगे। यहाँ से सिर्फ आपको एनो ऑक्सीजन को ये करना है, ठीक है। आपका ये एनो, चलो मैं कर ही लेती हूँ, ठीक है ना। तो आपको जो करना है वो ऑलराइट, सो ये कुछ इस प्रकार का है। और बाद में आपको जो करना है, ये जो है, ये हाइड्रोजन इसके बीच में 6 मेंबर रिंग तैयार होगी। और फिर बाद में आपको, अब ये यहाँ पर ऐसी पकड़ रिंग भी होती है, आपको पता है चेयर कन्फर्मेशन इज ऑल्सो इक्वली वेरी स्टेबल वन। तो चेयर कन्फर्मेशन में भी ये रिंग बन सकती है। तो नाउ आई कैन डायरेक्टली, तो देखते हैं डायरेक्टली हमारा किस प्रकार से बनता है। सो आई हैव दिस टू साइड्स वेयर, अब इसने ऑक्सीजन है, इसने हाइड्रोजन ये कर लिया है, और यहाँ पर जो है कार्बन है, तो इसके साथ NOH है। और यहाँ पर जो है, सी यहाँ पर NO हमने यहाँ, ये जो मैकेनिज्म मैं बताती हूँ हमेशा कि ये वाला मैकेनिज्म है NO के साथ, ठीक है। when R, if your R is now here, the removal of water molecule is a little bit not possible because of the steric hindrance. All right, because there are a lot of things that this hydrogen you cannot remove very easily, because this very next point there is a possibility of hydrogen bonding, है ना। आप बोलोगे कि मैडम आप इसके साथ C ट्रिपल बॉन्ड N क्यों नहीं, साइनो ग्रुप क्यों नहीं फॉर्म कर रहे हैं? क्योंकि इसकी और एक पॉसिबिलिटी है कि लॉट ऑफ हाइड्रोजन बॉन्डिंग्स आर पॉसिबल ओवर हियर। सो दैट्स व्हाई इवन इसका इसके साथ हाइड्रोजन बॉन्डिंग हो सकता है। सो बिकॉज ऑफ द हाइड्रोजन बॉन्डिंग द फर्दर रिमूवल ऑफ प्रोटॉन मे नॉट पॉसिबल। सो दिस इज हाउ वी कैन एक्सपेक्ट, only we can terminate the reaction at this point only. Okay, so we are not able to remove the proton because of the several factors, that is nearby we can have the two oxygens। तो यहाँ पर भी एक पॉसिबिलिटी है जो हाइड्रोजन बॉन्डिंग की पॉसिबिलिटी हमें देती है। सो दिस इज हाउ यू कैन टर्मिनेट द रिएक्शन एंड दिस इज द प्रोडक्ट, दिस इज द प्रोडक्ट। दिखने में थोड़ा डिफिकल्ट है, बट once you can identify the site, you can easily go through the mechanism. Now here let us see the mechanism. Now whenever you can see such type of structure, so you have to always see the equatorial and the axial। ये पोजीशन को आपको हमेशा ध्यान में रखना है कि आपके जो सब्स्टिट्यूएंट्स है वो किस पोजीशन पे है, एंड वेदर दे आर इन द सेम प्लेन और दे आर इन द डिफरेंट प्लेन, ठीक है। तो आपको सेम प्लेन एंड डिफरेंट प्लेन का जो क्राइटेरिया है, सेम प्लेन में अगर हो तो ही रिएक्शन इस टाइप में इस चेयर कन्फर्मेशन में होती है। डिफरेंट प्लेन में रिएक्शन कभी भी नहीं होती, क्योंकि मॉलिक्यूल दिखने में दिखता है, लेकिन इसका अगर हम लोग चेयर कन्फर्मेशन देखते हैं तो दे आर क्वाइट अवे फ्रॉम ईच अदर एंड द रिएक्शन इज नॉट पॉसिबल। ये हमने पहले इसमें भी देखा है। सो वेन एवर सच टाइप ऑफ रिएक्शंस वी कैन सी ओवर देयर। Now, the first thing I would like to explain over here, I can redraw the structure and we will see the this concept, the equatorial and the axial one. Now, All right, so this is your NO and ONO, and this is back the plane. Now when we tap the site, now alpha, beta, gamma, that is the first thing we have to see. Okay, alpha, beta. So this is the alpha, beta, gamma, and delta. Okay, so this there are the two hydrogen we can derive from this position, and the another possibility is this is the alpha, this is a beta, this is a gamma, and this is a delta. Again, I told you that there are two sides. So which side is visible? There are two sides that your nitro can abstract the proton. So which side is more visible? So I can draw. This is the first side. This is the first side. You can select, and this is the second side. This is the second side. All right. This is the second side. बताओ कौन से साइड से आप प्रोटॉन लेना चाहोगे? देखो मैंने स्टीरियो केमिस्ट्री यहाँ पर बहुत अच्छी से की है. ये दो है, ये see this carbon is already out of plane. See these two groups are already out of plane. That you must understand. Because this is below the plane and this is above the plane. So the first criteria is there is no question of abstracting a proton from this side because they are totally in the different plane. They are in a different planes. In a different plane. So there is no possibility that from this side the proton is available. So this side is not non-operative. This is non-operative. All right. Then look at the second side. Here we have again two hydrogens. One is above the plane, another one is below the plane. And here we can see that there is a possibility of, because they are very close to each other and they can form a 6-membered ring. So this side is a feasible side, operative side. Green side is a operative side. So I can draw the structure and you can see the so naturally you will get the formation of this thing, and here you can get the this type of structure. One hydrogen is there. All right, now I can draw the structure in this way. So here you can get the another radical. Now this radical has to be terminated, and this hydrogen is abstracted. So OH is already there. Now here we have NO. So NO will be forming a bond and we'll get the all right. Again, we have to terminate the reaction in a proper way. So this bond will, this is hydrogen, this bond will be collapse over here. And this hydrogen abstract a proton as they are present on the same carbon. So again, they can be easily abstracted. So double bond NOH. So here I forgot to draw the structure. So this is my answer. Any question? Any question regarding the Barton reaction? Isocomene and Cedrene Hirsutene. So these are the three naturally occurring products. I have shared the CRC Horspool book. In that book, the photobiology has been explained. So various natural products are also explained. So try to read this book in your vacations. So 10 days vacations we are going to have on the 10th of the from 10th of the November. Already, all right. So just read those books.